In this lesson, we're going to continue talking about data steps, and specifically we're going to deal with modifying and concatenating SAS datasets using the set statement. We want to, again, talk about the set statement in a data step for the purpose of modifying an existing data set. And we also want to discuss how to concatenate or stack multiple SAS datasets on top of each other. That would be done in a situation where you have data sets that contain different study participants, but quite often the same or similar variables. So a big overall overview of programming fundamentals and a reminder of what aspect we're talking about in this particular lesson. We use statements, and those statements build either procedures or data steps. And here we're going to be talking specifically about data steps and how they can be used to modify or stack SAS datasets. We've seen this overview slide before. That just walks us through the sort of a visual representation of getting from original non-SAS or raw datasets into SAS datasets, and then possibly merging many different SAS datasets down into one SAS dataset so we can run analyses or further modify it. So the first part of this lesson is going to be talking specifically about the step of going from here to here. In other words, taking an initial dataset, SAS dataset that contains information that was merged together from many SAS datasets, and then somehow further operationalizing it or modifying it using a set statement to create yet another SAS dataset. So let's talk specifically about modifying an existing SAS dataset using the set statement. Here's a data step, and in this particular data step, the goal is to create a new SAS data set that is temporary. In other words, it's going to the work data library, and we're going to name the SAS data set refine all WT, semicolon. And we want to start from an existing SAS data set, work.allWt. So again, we're starting from a data set that's also temporary. We've made it previously, and we made this specific SAS data set previously in the previous lesson, and the name of it is all WT, and we use a set statement to tell SAS, start from this existing SAS data set to create the new SAS data set specified in the initial data statement. So as a reminder, data steps always start with the data statement, and the purpose of the data statement is to name your new SAS data set and tell SAS where it's going to be stored. And then we're simply going to create a new variable named weight change or weight CHG using a basic mathematical operation in which we specify the new variable name on the left, followed by an equal sign, and then the mathematical expression, which will be end weight minus start weight. And you end that with a semicolon, and then we have a run statement ending with a semicolon. So the main point of this example is to show how we can start with one existing SAS dataset, in this example work.allWt, and create a new SAS dataset, in this example named work.refineallWt, and that new SAS dataset will contain all of the information from the original dataset, plus some additional information that we specify in the body of the data step. So here we're just doing, again, one basic mathematical expression, and we'll talk more about how to create additional variables and to operationalize variables within the body of a data step in future lessons. For this example, I quickly demonstrate one approach, and we'll learn more as time goes on. So try this code. You have an example of it in the editor file corresponding to this lesson. And then try running a proc print or a proc contents to look at the new dataset refine all WT. All right, so hopefully you were able to do that successfully, and then I'll just go over into the SAS code and demonstrate it also. Well, I had already created an editor file. This is the Lesson 5 editor file. And since many of you probably may have had a time gap in between the previous lesson and this lesson, it's possible you're opening SAS up for the first time and you had to start from scratch, as I did when I started this particular lesson. So I'll just start from the beginning by running a libname statement to assign my libref epic to a location on my computer. Submit that. Then I'll come down and run some of the same code we've seen in previous lessons to sort the data sets that I want to merge, and then merge them by ID number. Submit that code. The log file seems to indicate everything worked just fine. And then I'll come down here finally and run my data step where I'm going to create again this new data set called work.refineAllWt, starting from the existing SAS data set work.allWt. Sorry, and I need to remove that too. I accidentally had the wrong name of the existing SAS data set. So that's a good place to reinforce that if you tell SAS, provide a name and location for a data set that doesn't actually exist, the data step won't work. The reason this data step will work is because in this set statement, I am pointing SAS to an existing SAS data set that is in the work library. How did it get there? I created it just above in this data step. So I'll highlight that as well as a proc print, and then we'll submit that. We can check the log file. We get a little bit of information here. There's a note about missing values. That simply means that some missing values were created because there were missing values to some of the arguments in this expression. Don't worry about that now, more on that later. More importantly, we see that there were 6 observations read from the dataset work.allWt, and the dataset work.refineAllWt has 6 observations and 6 variables. And if we look at that new output dataset, these are the results of the proc print. Now you see that we have a new variable called weight change. So we've successfully modified our existing dataset AllWt. We've created a new dataset named refineAllWt, and that new dataset has an additional variable called weight change. Here I'll show you a couple of options that can be helpful within the context of a set statement, specifically the keep equal, rename equal, and drop equal options. Effectively, what these allow you to do are modify the existing output data set based on information in the input data set. So in this example, you're starting your data step with the data statement where we tell SAS the name of the new output data set that we want to create. In this example, it will be a temporary SAS data set in the work library named demo red, short for demo reduced. And we want to start from a data set that is contained in the epic data library that is named demo. And we know that we're starting from this data set, or SAS knows that we want to start from this existing data set because we're using the set statement, as we've talked about previously. Now you can use some options after the specification of the data set by putting the options in parentheses, and specifically we're going to use the keep equal option to tell SAS that we only want to keep the variables named ID, age, and region. And then we're also going to use a rename equal option, which is going to tell SAS any variables that we might want to rename. And in this example, I'm just going to rename one variable, the ID, the variable ID will be renamed to the variable ID number. And then you put in the appropriate close parentheses, and then you can highlight the code and run that and take a look at the results. So here's the example in the SAS code, and I'll quick run a proc contents. And that just simply demonstrates that after that's all said and done, we only have the three variables that we asked to be kept in the data set: age, region, and ID. And the original variable ID has been renamed to ID number. So this is the actual variable name in the data set. This label is a label that was applied to it to give the user some additional information about what that variable meant. And we won't be talking about labels in this course, but they're easy to read up on in the SAS help menu if you're interested in learning more about labels. Alternatively, you could also use a drop equal statement. That's specified here, and as you probably imagine, based on what we saw for the keep equal option, drop equal simply tells SAS which variables to drop from the data set. And if you run this, you'll see that the results are identical between this data step and the previous data step, in that we still have age, region, and ID number. We just got to that endpoint in different ways. So knowing keep equal and drop equal is helpful, because oftentimes there are situations where you only want to keep a certain few select number of variables in the data set. There may be 1,000 variables in your data set, but you only need 10 for the analysis, and you want to keep things clean and easy to manage and use less memory on your hard disk. The keep equal option is a good idea in that situation. In other situations, you may only want to drop a limited number of variables, and then the drop equal option is quicker and more efficient. For example, you may be sending a full data set out to a colleague, but before it can be emailed or transmitted, you need to remove some personal identifiable data, social security numbers or names or something of that nature. You could use the drop equal statement to quickly and easily drop those variables. Here I'll show a quick example in which we start from an existing data set called work.allwt2. We've created that previously. And we want to essentially save that SAS data set as a permanent SAS data set. In other words, maybe we've spent a lot of time working to create this data set allwt2, and now that's in a form that we want to analyze. So we want to save a permanent copy of it. And to do that, you can use this basic approach, which is fairly intuitive based on what we've learned so far. So the basic approach is that you, again, use a data statement to start a data step. In that data statement, you specify the name of your new SAS data set and the location. So refine allwt is the name of your actual data set, and the location will be the Epic data library, which is a permanent SAS data library. And you use the set statement to tell SAS, I'm starting from a data set located in the temporary work data library. The name of that data set is allwt2. And then you have a run statement. Altogether, this is effectively no different than having an Excel file open named allwt2 and using the Save As option to save it in a different folder on your computer with a different file name. You can go over into the code and demonstrate this. Here is the syntax, and before I actually run it, let me go into the Epic data library. Simply show you that in this data library right now, you'll see these are in alphabetical order. There is no data set called refine allwt. Now, as soon as I run this data step, that data set will appear in here. I'll highlight it, submit it, and then you see now we have a SAS data set called refine allwt in the Epic data library. So now I just want to talk through some other important and conceptual uses of the set statement. Specifically, I want to talk about using multiple SAS, or excuse me, using the set statement to stack multiple SAS data sets specified within that set statement. Let's consider this example. This is a made-up example of a study with multiple centers. Each center has 4 study participants, and each of those participants was assigned to a treatment, either treatment yes or treatment no, by 1s and 0s, and then blood pressure was measured at time 0, the baseline, and time 1, a follow-up. Okay? And this was done in 2 different locations. So in the end, you end up with 2 different data sets. The location number 1 or center number 1 puts their data into a SAS data set and sends it to you, and somebody at the data center number 2 does the same, but now you have 2 separate SAS data sets. They contain separate patients or study participants, but they have essentially the same variables, and in this example they have identical variables. So all participants have a value for treatment, there's a treatment variable, and all participants have start and ending blood pressures with T0 BP and T1 BP as the actual variable names. And then, of course, an ID number. And again, you'll note that the ID numbers in the first data set are 1 through 4, where the ID numbers in the second data set are 5 through 8. So these are different participants, but they have the same data collection. Now you can use a set statement to effectively take these 2 separate data sets and get them stacked and combined into one data set that would look more like this. So now instead of 2 separate data sets in the previous slide, or as the data originally came to you, each data set having 4 participants, now you have one data set that contains 8 participants. And the way to do that is quite straightforward. You can use a data step and then a set statement within that data step where you specify the names of the SAS data sets that you want to stack. So in this example, I'm creating a new SAS data set. It's a temporary SAS data set called final. And that new temporary SAS data set named final will be populated by the observations and variables contained in work.n99 and work.n01. And then you have a run statement. Okay. So this code effectively takes these 2 separate SAS data sets, puts the information into a new temporary SAS data set called final, and it would have this structure. So this type of approach is necessary in multiple settings. I talked about the multi-center type setting. Another situation where you would use this approach is when studies have serial cross-sections. So for example, NHANES, the continuous NHANES, is designed so that every 2 years the government goes out and enrolls about 10,000 participants, and each survey cycle or each cross-section enrolls different study participants. For example, in 1999 and 2000, 10,000 individuals in the U.S. were enrolled into one cross-section of the NHANES study. And then in 2001 and 2002, a separate set of 10,000 individuals are enrolled into a second cross-section. So if you wanted to take those data and combine them into one data set so that you would have a larger sample size to look at various study questions, you could use the approach we just talked about to get them stacked. And the exercises for this course follow an NHANES example. So if you go through the exercises, you'll see how set statements are used versus merge statements. In summary, we've talked about how a set statement can modify and resave an existing SAS data set. We also talked about how set statements can concatenate, or in other words, stack multiple existing SAS data sets. And to summarize what we've talked about so far in terms of data step fundamentals, a reminder that data steps always begin with a data statement. In the data statement, you're providing the name of your new SAS data set and the data library where it should be saved. Then you'll always follow the data statement by some sort of statement that will identify the existing data sets that will be used to populate your new data set. And most frequently, the vast majority of the time, you'll use either a merge or a set statement to identify those SAS data sets. It depends on the context. So merge statements are being used when you want to merge together observations, usually by some sort of unique identifier. You have 2 data sets or 4 data sets, and each data set contains generally the approximate same study participants, but different variables, and you want to merge them together so you have all participants and variables in the same data set. That's when you use a merge. If you want to use a set statement, generally you're using that to simply modify an existing data set, or you may want to concatenate or stack together multiple SAS data sets. Again, we went over specific examples of each of those within the context of this most recent lesson. And then finally, data steps always end with a run statement.